Hey there. This video will see the last method we use to evaluate and compare between economic alternatives or engineering alternatives, which is internal rate of return. So we covered before future worth, annual worth, present worth, but in internal rate of return, IRR, we take another approach to analyzing cash flows. So present worth, future worth, annual worth, we are given MARR and we put that equal to I. So I is the interest rate we use in the tables and formulas. And we solve for each one of these, present worth, future worth, and annual worth. In internal rate of return, we set I to be unknown. We ignore for now MARR. We have it, but we ignore it. And we solve the cash flow to find I, which we call here I star, that will make the value of the cash flow equal to 0. And the value here, for this case, I'm showing it's future worth of the value, the future worth of the cash flow is equal to 0. Once you set that equation equal to 0, the only thing unknown to you is I, and you'll find I that actually satisfies that. And this I star value is what we call internal rate of return. So internal rate of return is the value of return of this investment. It's the one that makes the outcome and the inflow and outflow of this alternative or project equal in worth. And you have to make them equal in worth either as present worth or future worth or annual worth. So it kind of, you using the other methods, present worth, future worth, annual worth, to be able to find that balance point, that IRR point that makes the cash flow balanced. So now if we kind of summarize how we evaluate economically an alternative, is you have IRR on one side and then all other alternatives, present worth, future worth, annual worth, on another side. And because IRR is a little unique in the approach it uses. So to summarize, in IRR, your interest rate is unknown. It's differentiated between interest rate and MARR. MARR is my benchmark, is the goal of the return, the goal rate of return that I want to achieve, at least. But for now, I don't know. I set it aside as my goal, but I'm looking for what's really this investment is giving me, which is IRR. So you formulate now the cash flow formula as either future or present or annual worth. Set it equal to 0, find I that makes it 0, and that will be IRR. Once you have IRR, you compare it to MARR. And the idea here, if IRR is more than MARR, then this is a good alternative for you. For the other side, present worth, future worth, and annual worth, you set I to be equal to MARR, you go through the interest calculations, and then you end up with a value that doesn't have a meaning really. It's like we discussed before, the sign of this value is the meaning. So if it's positive, then this value, either present, future, or annual, good news, you're getting something more than what you're asking for. If it's negative, bad news for you, because your MARR is high and you're getting something less than your MARR. So you can see here the difference. And now when we compare between multiple alternatives, it's just repeating that process for every alternative. And for IRR, you pick the one that gives you the greatest IRR. Of course, you ignore the ones that are less than your MARR. So why RRR is actually very popular. Actually, investors and people like to think, have that thinking in the same lines, on the same lines of IRR. First, people think profitable, like think in the lines of profit. How much this investment will give me, because your MARR is very subjective. It can change over time. Economy changes, your way of securing capital changes, but an investment return is fixed. So it's kind of a label. This investment is 5%. This is 3%. This is 2%. So it's kind of a single rate that describes the investment or the alternative. And also IRR is independent metric. It doesn't, like the present worth, it doesn't depend on setting your I value to be equal to MARR. Because if your MAR changes, I changes, then your present worth changes. But IRR doesn't change. It's not dependent on any external factor, which is here your MARR, the economy. So this is why it's called internal. So these are the two reasons. First, it's a very lingual kind of, the language of the economy is what's the return of this investment or alternative. And the other thing is it's not impacted by any other external factors that can change its value over time. So these are the reasons why IRR is kind of the most popular way of comparing between alternatives. So let's go here over examples. So this company here is considering to buy this new machine, gang punch machine, and they are going through that there is the first cost of 100K and its life is 15 years, and it's kind of annual labor costs will increase by 2,000 a year, but when you're comparing it to the annual raw material that it will save, it will decrease by $12,000 a year, and your MARR is 5%. So part A is what's first IRR for this punch machine, and the second thing is should we or this company buy this punch machine. So let's see here the process of calculating IRR. So you can see here I have initial investment, but then there may be some confusing wording here. So the annual labor cost would increase by $2,000. So this is not G. This is just, I used to have an annual labor cost of, let's say, 100K, and then because of this new gang punch will require highly skilled labor, so I have to pay them more. So it will cost me 102K instead of 100,000. So your cost will increase. So you're sinking in cost more by 2,000, but you're saving on the material cost by 12,000. So in net here, you're actually saving. It's kind of there's an income. This cash is not spent anymore. You can have it as an income in your budget. So it's $10,000 a year. So if you draw the cash flow, you invest $100,000 in return of expecting to get $10,000 a year savings, and this is over 15 years. We're not given I here. We're looking for actually I star that makes this present worth equal to 0. And I'm using here present worth, but you can actually calculate this cash flow as the worth of it as present, future worth, or annual worth. So I'm just using the present worth approach. Now we'll use interest formulas, or we can use also tables. So for this case, I will use only the tables. I can take out the present P given A factor given here and plug in the formula for it, or I will look for its value from the tables. So let's use here the interest tables, and what I will do is I will do these trials of plugging in different values of I and P given A and find what's the present worth I'm getting. My goal is to get a perfectly 0 present worth, which is hard to get, but we'll see. So I%, this is kind of, hunting blindly in the beginning. You don't know where's really I, but let's say I will try 4%. So 4% give a factor of 11.11839. Plug it in the formula, that will be the factor you'll end up with. The value of present worth, so you see here it's a positive 11,000. Now should I try 5% or 3%? You try and see which trajectory you're going to. And my trajectory that I want to is actually to decrease. I want to go to 0. So I will try 5%. And you see now I'm decreasing. With the present worth here is decreasing. So I'm in the right direction. It's just a matter of keep going with a higher interest rate, so I will get less present worth until it's 0. So I try 6%. Now I see it's negative. even if we confirm that I'm in the right direction, I try 7%, it's getting more negative. So this means that my I star, or internal rate of return, is between 5% and 6%. So now you will use interpolation to see what point between 5% and 6% would give you an IRR, or that gives a zero present worth. So solving whatever trigonometry way or interpolation way you use, I will end up here with 5.57% IRR. So regardless of your MARR, this investment or this decision has a rate of return of 5.57 IRR. So this means that for part B now, should this company buy this equipment? And the answer is yes, because their MARR is 5%, and this one is giving them actually 0.57% more. So that's a wise decision to buy this machine. So at the end here, IRR, so actually this title here is not correct. So I'll fix it. IRR is a very effective way of analyzing investments in general, or comparing between engineering alternatives, because it tells you right away a lot of information about this investment. Unlike present worth, we don't get anything about the value, we only get the sign of it. So sign positive, good news, negative, bad news, that's it. But IRR has a lot with it that can tell us about this investment or alternative. All right, thanks so much, take care, and I'll see you in other videos.